Okay, what we have here is a Predicta Princess chassis, a 10L43. I've already gone through and cleaned up the PC board a little bit so I could see what was going on. I sprayed some this stuff into the tube sockets to make these tubes come out with without a lot of stress. After I got them out, I used one of these pin straighteners just to make sure everything's good. So don't want to stress these pin sockets any more than I have to. I'll be checking them in a little bit. I'll just explain that later. But one of the very first things I want to do is just kind of give an overall look. That doesn't look original. I see some, it's got the Black Beauty caps in here. That one's got a crack right down the side. Another Black Beauty. Doesn't seem like it had too much work. Somebody's put a fairly recent cap here, but that's the only thing I'm seeing that's got any real work. I went ahead and pulled off the IF shield, mainly to get these tubes out. They're kind of hard to get out. There's little access ports here on the sides of these shields, and what you can do is, if you get a tube that's really stuck in there hard to get out, you get a flat tool and you put it in the bottom of that and kind of twist it, and it'll pop the tube out rather than just tugging on it. You don't want to really pull on these PC boards real hard. Remove the cover for the fly. Getting ready to do some checks. So, I figured I'd just go ahead and do a few rudimentary checks. So, using the predicta schematic, I'm going to go through and do some resistance checks just to see where we are. I don't recall it having a resistance value for the primary of the power supply. I'm going to do that first. Make sure the switch is turned on and the switch was broken and bypass just connected together, so it's always on. And what I'll do is I'll just go across the switch, the terminals here, and see where I am. Having a hard time getting a good connection on that. Let me try a different approach. I'll use navigator lead on one side. Do that again. So again, what we're trying to do here is just kind of get a baseline to see if the hard parts are going to at least be not shorted. Okay, I get about 2 ohm, 1.8 ohms. I think that's pretty much correct. I'll check against another predicta. Actually, I expect that to be a little bit higher. I could be wrong about that though. It's kind of hard to tell sometimes. Next, I'll check the secondary side of the transformer, which goes from that from this little surge protector here, and it goes to right here. Let's see what that reads. About 3 ohms. Let's see what we get on the schematic for that power supply transformer secondary. I see 3.4 ohms. Right here is 3.4 ohms, so that's okay. So we're going to move on to the flyback, because clearly that's always an issue. Okay, I have 350 ohms from the plate of the high voltage rectifier tube to pin 4 of the flyback. So we'll just move this to pin 4, and I'm going to get in here and get on this plate lead and see what we get here. 375 ohms. That's pretty good. It called for 350. The next reading is 10 ohms from pin 4 to pin 2. So I'm already on pin 4. I'll jump right to pin 2. 12 ohms instead of 10. Alright, I'll take that. The next reading goes from pin 2 to the actual yoke leads. So we'll go to pin 2, and the yoke leads on this thing are pin 3 and then pin 8 of this funny looking little plug here. So we got to find pin 3, which is right here, I believe. Pin 3. I think that's the correct one. 12 ohms. And then from pin 3, I'll just clip up to the back side of this thing. The pin 8, which I believe is right here. It's supposed to be 10 ohms. We're looking good. Okay. So it looks like the yeah. So it looks like the flyback transformer resistances are at least checking out. While we're around this connector here, which the yoke plugs in, I'll go ahead and check the secondary of the vertical transformer, which is right there. And it's not focusing very well, but that says 2.5 on the secondary. So what we'll do is we'll just plug in to those two leads, which is going to be right 11 and 9. 11 and 9, I believe that's that. 2.5, that looks good. And we're going to go ahead and check the vertical out transformer's primary. That's a secondary, it looks good. Next we're going to check out the secondary, which is going to be this pin right here. And the 275 volt source. And according to this, that should be 425 ohms right there. Darn it, I wish this thing would focus up close. But I'll go ahead and hook this up. And go to the 275 volt lead, which is right here. And what do we get? Oh, lead came off. Hold on. 275 volt lead, which is right there. And I get 415 versus 425. So we've checked out the flyback resistance, the vertical out resistance, the primary, which I'm not, the power supply, which I'm not sure about the primary. While we're doing this, let's check the audio. I don't know any reason why it would ever be out, and their audio being bad. What the heck? And what do I get there? 0.3 ohms. I have no idea if that's right. Sounds probably reasonable. Let me see if it shows that on the schematic. It does not. It does show the secondary as being 270 ohms, so we can check that real quick. Secondary, let's see, that's going to be right over here. There's the plate lead there, and the other side of it. What did I say it was? 270 ohms. Okay, let's check that audio out. 270, come on. Yep. So that looks good. So far we've checked, now we checked the audio out, the vertical out, the horizontal out. I guess this is the choke over here. I'm not sure how to get to the choke leads very easily. Let's see if we can just look at the schematic. I really doubt there's going to be a problem with the choke. Going back over here. So the choke is supposed to be, I think it says 41 or 0.41. It's got to be 41 ohms. And if I read that right, it's on the other side of this doubler diode cathode and a 275 volt source. So that should be pretty easy to get to. So we're going to go to the, bear with me. I've got to get a tripod and do this the way Bob does his overhead shot. Alright, so we're going to hook up to the choke, which is going to be right here. That lead and the 275 volt source, I believe that's correct. Yeah, 275 volt source right here. Let's see what we get. 38 ohms instead of 41. Good enough. All right, so we feel pretty good about the basic hardware. The next step will be to go through this and recap the obvious stuff. I have never pulled a board on here, but after watching Bob Anderson do it so many times, I'm starting to feel a little gutsy about the whole process. So I'll probably end up pulling this PC board so that I can do a full replacement. I'll replace every single capacitor in here. I think the resistors, I don't know. I kind of don't like replacing resistors unless I know they're bad, especially these old carbon comps. I don't know why. I just don't like new stuff going into these things. I know there's like it sure looks nice if you put brand new parts, and I'm sure the reliability is better and all that other kind of stuff, but there's just something about the old carbon comps. In fact, I even have a source of old carbon comps, so I may very well end up pulling the PC board and replacing the carbon comps with new old stock carbon comps after I've checked their values and whatnot. I'm trying to think if I missed anything on the PC board here. I don't think so. I already went through and checked the front to back ratio of these two top hats using my old school Simpson. Let's see if I'll try to demonstrate that real quick. I think it's kind of a good way to do things. I know, again, referring back to Bob's recent troubles on these diodes, which is kind of unusual, really. I've never heard of a diode behaving that way he described it, but I guess it happens. Hang on while I hook this up. Go ahead and put that one on there. What I'm going to do is use the Simpson to check these diodes out. And what I do there is I usually set it at about R100, and that's what I really like about these things. This really makes this handy. Go over here and hook up to the diode. There it is. And let me see if I can do this. I'm trying real hard, folks. Bear with me. Mouse balances the camera. And then here I get it in the frame. Okay, I've got it hooked up to the diode. Then I just go from see, there's a switch down here that goes DC plus, DC minus. Switch it to DC minus. Boom, and it drops down. DC plus, DC minus. Okay, so that one looks pretty good. Now we'll go to the other diode. We'll do the same process. Okay, ready? Hope you can see. I think my big hand. And back to DC plus, DC. And I think the general rule of thumb is you want at least like a 4-to-1 ratio here. So I'm, just for the heck of it here, if I'm at 100 times 100, so that's what, 600 ohms to 15,000 ohms. It might be 10-to-1. I'm not sure, but basically you want a big swing there. And that's how I do a quick check on my diodes, make sure everything's working okay. So I feel pretty good about the top hat diodes. That's these two guys right here, by the way. I'll probably end up having to restuff these. In fact, I know I'll restuff it. This cap have had go bad on quite a few predictas, so that one's got to go. Doublers always, they have a very hard life. That being a newer cap might actually be okay, but what's the point? Anyway, more to come later. Thanks.